In this video, we're going to go through Learning Target 333, which is talking about inequalities, graphing systems of inequalities. So we are given two inequalities to graph. We basically just want to graph both of these on the same coordinate plane and then see where they intersect. So the first one I'm going to do in green. And this one is just in y equals mx plus b form, so our slope-intercept form. So we want to begin with b, which is -3, and move with m, which is 3 over 4. So I want to go up 3 and over 4, and up 3 and over 4. Then I want to look at my inequality symbol. Since it has the line underneath the or equal to part, I do want to use a solid line. You should make sure that you are using a ruler, but this is a good estimation for us today. And then we need to do some shading. I would highly recommend you do the shading for the first inequality before you start the second one. It's very hard once you get two lines on there to know which goes with which. So for this one, I want to plug in 0 for x. So I have y is less than or equal to 3/4 times 0 minus 3. Well, 3/4 times 0 we know cancels, so we're left with y is less than or equal to -3. Well, here's -3. If it's less than or equal to, we would want to go down, which means this whole side gets shaded. Okay, so I have my first inequality there. Now let's do the second one. This one's not in y equals mx plus b. I think it'd be equally as easy to get this into slope-intercept form by just subtracting 3x from both sides. Or you can do the x-intercept, y-intercept method, whichever one you prefer. So for x-intercept, we're going to plug in 0 for y. Well, plus 0 is nothing. So we have 3x is less than 2, or x is less than 1.5. Nope, I did that backwards in my head. X is less than, we're going to divide by 3 on both sides. So x is less than 0.6 repeating. So I want to put 0.6 repeating on the graph at the x-intercept. That's kind of close to, like, it's definitely more than half. I can say that's a good estimation. Then our y-intercept, we plug in 0 for x this time. So 3 times 0 cancels, and I'm left with y is less than 2. So I'm going to put a dot on the y-axis at 2. And then looking back at my original, since this does not have the or equal to part, this is going to be a dash line. Make sure you use a ruler so your dashes don't look all crazy and squiggly like mine. But there is our red line. So now we already did the work to shade for the red one, and that's this work right here. And so we look at our very last line that says y is less than 2. So if y is less than 2, that means I'm going down from here, which means this whole side of the red line gets shaded. When you're shading that second one, just kind of ignore that the first one's even there and shade that side of the graph. So now the solution set, you're going to be asked questions about, and the solution set is really just the double shaded area. So you can clearly see like the area that has both green and red. There's a couple things to keep in mind. Very obviously, if we have a point like right here, that's in the double shaded area. That's very clearly part of the solution. But there are a couple weird things that happen. If we land on a solid line, so let's say we have a dot right here, that's on a solid line. It's also within the red shaded area. So it's part of the red solution set. It's part of the green solution set, so it is part of the overall solution. But if the same thing happens if I put a dot on the dotted line over here, this point is definitely part of the green solution set, but it is actually not part of the red solution set because that line is dashed. So we have to be very careful when we're choosing points or we're being asked questions about points. If it's on a dashed line, it is not part of the solution set.